Moving down here, a couple of different questions you might get. Going to have to think back to geometry here. Parallel and perpendicular lines. Two non-parallel perpendicular lines, non-vertical lines are parallel if and only if they have the same slope. All vertical lines are parallel. So what that's saying is that if I have two lines that are parallel, remember parallel means that they're in the same plane and they do not intersect. So these lines here are parallel. They are slanted perfectly the same. If they are slanted perfectly the same, that means they have the same slope. So parallel lines have the same slope. Parallel lines have the same slope. Whoops. Let's try that again. Same slope. On the other side, it says perpendicular lines, two non-vertical lines are perpendicular if and only if their product of the slopes is -1. Vertical lines and horizontal lines are perpendicular. What that means is that perpendicular lines, if you recall, are two lines that intersect at right angles. So there's a right angle. And perpendicular lines, another way of describing this, are called opposite reciprocal slopes. Opposite reciprocal. Remember, reciprocal is a word that we've already used, is a fraction that's been flipped over. Opposite in terms of math means different signs. So some examples of opposite reciprocal slopes might be a slope of 2/3. Its opposite reciprocal is -3/2. So opposite sign and the fraction's been flipped over. Or -4/7, its opposite reciprocal would be 7/4. A whole number like 3. Its opposite reciprocal would be, well, I would need to put the 3 over 1 to make it a fraction, so its opposite reciprocal would be -1/3. And a number like -1/4, its opposite reciprocal would be +4 over 1, which could be simplified to 4. So that's examples of opposite reciprocals. So this one says, write an equation in slope-intercept form. Write an equation in slope-intercept form of the line that passes through 3, 7 and is parallel to the line with the equation y equals 3/4 x minus 5. So we've got the point already, it's 3, 7, but what's the slope? Well, if we're writing an equation that is parallel to this equation, that means it has the same slope of that equation, and the slope is right here, 3/4. So just like we've done already, we're going to write the equation of a line that goes through 3, 7, and we already know the slope. The slope is 3/4. So we go right back to slope-intercept form, y equals mx plus b. So we know y is going to be 7. M is from our equation of 3/4. X is 3. And again, we solve for b. We will take 3/4 times 3. That's 9/4. Then we'll subtract 9/4 from both sides. And we get b equals 19/4. So that means the answer is going to be y equals our slope of 3/4 x plus our new y-intercept of 19/4. And then the last one, write the equation of in slope-intercept form. Write the equation in slope-intercept form for the line that passes through 5, -6, and is perpendicular to the line with the equation y equals -3/2 x plus 7. So on this one, since we're writing the equation that's perpendicular, we don't want to use -3/2 x in our equation. We want to use its negative reciprocal, and its negative reciprocal would be +2/3. So that's what we're going to use in our equation. So again, we go y equals mx plus b. So that'll be a y value of -6 equals 2/3 times our x value of 5 plus b, and we are solving for b again. So -6 equals 10/3 plus b. Subtract 10/3 from both sides. We get b equal to -6 minus 10/3 is -28/3. Running out of room here. Let's try to squeeze that in there again. -28. Whoa, I don't know why it did that. -28/3, that was weird. Which means the equation of my line will now be y equals 2/3 x, that's the slope that we used, minus 28/3. And there is our answer. So to sum up, almost every problem we did today used y equals mx plus b in some way. You have to find the slope, and you have to have a point in order to find the equation of a line.